Hey Kata, I need to design a 3D model. Do you want to come along for the ride?
Uh, Wait, are you designing a 3D printer car? A 3D printed car?
Let's start from the beginning. Okay.
Oh, I can help. I can help. I have one. Ready. But
What's that?
actually, I use it. It's my personal fork. What kind of model is this?
Uh, You're eating? So
Mm,
I'm gonna tell you at the end.
Thank you.
Okay.
I understand.
Okay. So the object that we need to reproduce is this one. I mean, it's a rubbery, and so it has
Mm.
this.
People, guess in the comment what it is.
Okay. So it has this shape. I mean, it gets here, then it has a flat bottom. It has these two pins, and so let's get a few measurements. So what we're gonna need
Mhm.
is we're gonna need the length, and I mean this is problematic because it's rubber. So the more you push, the smaller it becomes. So the measurement is gonna be approximate. So we are gonna need uh, that length. We're gonna need this other side. We're gonna need the thickness of the
Yeah.
base. We're gonna need the total thickness so that in this way we can measure the actual thickness, I mean the actual height of the pin. We're gonna need the diameter of the single pin. We're gonna need the size of the wall, the thickness of this wall. We're gonna need the distance between the two pins, and in this way we are going to be able to measure, to compute all the rest of the values. So
I have a question. So, adapt. I'm pretty sure that you already done that.
yes, I already have all these values,
Okay.
so let's start from there.
Show me the
And
values.
so uh, these are the first set of values that we're gonna need.
Okay.
And so effectively the base is 44 by 22 millimeters. Sorry, American
Po,
folks, we're going metric.
matrix.
Metric. Okay.
Yeah. Go for the
The
matrix.
the base height is 5.8, total height is 13.8, and we have all the other measurements that we just went through. And now that we have them, we want to go and effectively start building something out of this. And so, well, we need to expose the function. And the first value, if you saw the previous episode, you know that the first thing that I always put in these designs is the segments. And this is going to be a tunable knob that tells you that the quality of the design, the precision. And so with that, we're gonna work with a low number of segments so that we can iterate rapidly, and then we're gonna go deeper. So let's compute some values out of this. And well, the first value is more eyeballed. We are calling it the height slice, and effectively is how much extra we want to slice off of the base to make that flat base. And so I just eyeballed it to 2 millimeters circa. And then
Okay.
we care about the total height, which is effectively the height that we want plus the height that we want to slice off. And
Oh,
so
okay.
let's start
Probably
from.
you could
Yep.
make all of that parameter if you want.
Yeah, I mean, all this could be parameters,
I
and we
remember
can
the
go
last
and
episode.
yeah, go and watch it, folks, if you didn't watch
Yeah,
what this
the
tool
link is on
is.
top of the video.
So we're going to start from an ellipsoid. And I mean, the radius is half of the width, half of the depth. The height is this total height. The radius height is the total height. And we are shifting it so that the slicing plane is the XY axis. So it's here.
Nice.
You can go, and it's here. You see that we are going to slice it there and see what happens. So next step, we're going to go, and for now, let's remove this ellipsoid, but we're gonna go and build this harness. This harness, as you see, is something, anything below the XY axis,
It's something
and yeah, everything above.
it's something from a sci-fi film.
Yeah, it looks, it's floating. So effectively, this is the area that we don't want, and the empty space is the part that we want to keep from the design. And effectively, if we put all of this together, we are going to get the ellipsoid from before. We're going to subtract these two cuboids together, and what we get at the end is the base. So we have this flat slice on the bottom, and we have this shape. The next thing, the next thing that we're going to compute is that we want to work on the pin. So at this point, we need a few values. So let's call this the base. So let's compute a few extra values, which are, well, we measured the diameter.
Okay.
So we need the radius was half of it, and the inner radius is the radius minus the wall thickness. And then we care about the height of the pin, which is the total height of the object minus the base height. That's going there. And then we have the pin X shift, which is we measured the distance between the two pins. Well, the distance of the two pins plus the pins. So if we subtract effectively twice the radius, so the diameter, we have the shift of the distance between the two centers. Half of it is how much we need to shift it out of the center. And at this point, we can go and build our pin. So,
okay,
this is our pin, and so let's return it, and we see, I mean, it has this shape, but let's actually go and
a big cylinder.
Yeah, let's probably
with a hole in the middle. Ciambella.
Let's see how it is made.
Little stretchy for a ciambella.
Yeah, a bit. So effectively, we're starting from this rounded cylinder. So it's cylinder with a bit of small donut. At this point, it's more like a Berliner, but yeah. So we're using this value, which is the head radius, to try to smooth it out. And the idea is that we want to have, similar to the original, not a flush cut. We want to have a bit of a helper to start the insertion.
Okay.
And
you're flushing, so
yeah, I always flush. So
this is a suggestion for the model. So comment with your guess.
You're gonna figure it out later. So again, we're just building an harness that we want to remove from it, which is effectively everything below, so that it's again flush. And this is introducing the hole. And so if we go and put everything together, we actually have our pin. It's here. And last but not least, let's actually put everything together. And we're gonna go and say, okay, I don't want to see just the pin. I want to see the base together with two pins that are shifted. Well, the X shift is that measurement that we computed before. Is that the distance between the center of the object and the center of the pin, one in one direction, one in the other. Nothing in the other direction is aligned with the center. And we are moving up as the height. of our
Let
object.
me do a check. I'll try to check if it's correct from our long distance relation.
Okay, so here it is.
It's like that in my monitor.
Yes. So we are here, and now we're gonna go and crank up that configuration. So 64, you see that it's taking a bit longer, but it's getting smoother. It takes longer to compute, but it gets smoother. We can go
Nice double.
128. And it's gonna take a lot longer, but it's gonna get a lot smoother.
Not double anymore.
So
not double.
We can probably push it. Well, it actually gets 4 times longer, but we can push it to
it's okay.
Probably a bit more, but we at this point we just need the our STL file because we are going to print it. You can choose various formats, but we care about, in this case, STL binary because I want us to get the file. And so, yeah, we just downloaded our file and we have on our machine. And now it's time to put it in the slicer, and we're gonna totally skip that step. Yeah, and this joke is only Italians that use 3D printers from a specific brand are going to figure it out. But
so everyone,
yeah,
potentially,
I hope so. We're gonna totally skip this. If you want to see us used a slicer, go there. But effectively, the interesting part of that step is that we're gonna use a TPU. So we need to, again, it's a elastic material, so we're gonna tune a few settings. But at this point, let's go and print. And here it is. So
sorry.
Always eating. So here it is.
I think it's longer printing.
So the shape is effectively the same. We have more or less the same angle. Well, I mean, I eyeballed it correctly. The distance between the pins looked correct. The size of the pins looked correct. Again, this is TPU, so it's elastic. One thing you may have noticed during the time lapse is that if you think about it, this is a string-in test. This is literally 2 pylons, and you keep having the head moving between them. So stringing is when you have a bit of material remaining while you're moving, and so you have all these strings connecting them together. This one we went and cleaned it. But the problem specifically is that my printer doesn't have a direct drive. So if you don't have...
Do you want a Prusa?
Yeah, I mean, if Joseph wants to send us one, it would be great.
Yes, send us one. Please watch us and send us one. Follow us also if you want.
Yeah, we're going to figure it out. We'll probably know, but we will see. So effectively,
we are asking too much, probably.
Yes. So effectively, the problem is that the material, the filament is elastic, and so when you're trying to pull it back, it's still there, so it's still pushing out a bit from the previous one. So effectively, with my 3D printer, with this material, that's the best you can do. But maybe one day we're gonna have a Prusa.
But also for the old part of the cylinder, it's easy to print, or you have some problem in that part, or the cooling is okay?
No, for the hole is not a problem because I printed it upside down. So I mean, with the pylon up, so with the pin up, so it's not a problem. If you had to print it this way, it would be a nightmare. So I went with.
I mean, it seems a small part, so probably without cooling in the 3D printer with elastic material. I don't know.
No, not that. It's not that small for.
With
I
cooling.
ended
In your
up.
case, probably you have cooling. Yeah.
Yeah, I have active cooling, everything, but
Okay.
and so well, this wasn't the only one. We have other.
Oh,
And
they
so
can play together.
yeah, so I actually need to get on in a car right now because I need to bring this to my parents because this is something for them. So
Hurry up!
yeah, wait for the post credit to see what.
We can see also
Yeah,
this weekend.
you're gonna see what this is going to be. So you're gonna laugh. Okay, so
You really need in your life that kind of thing. Yeah.
oh, definitely. See you next time, folks.
Bye.